we want to have a rule of some rule for integrations. Now, when you take the derivative of, say, x cube, you get 3x square. And from this example, we concluded that the integral of 3x square would be x cubed plus c. So notice that whenever we take the derivative, the exponent goes down by 1. Now, this 3 is a constant. It can be pulled out. So it tells me that 3 integral x square will be x cubed plus c. And then integral of x square would just be x cubed over 3 plus, well, I should divide the c by 3 as well. But the point is, I again get some constant. Maybe I could have used a different constant here, say c prime, and then finally c prime divided by 3 is c. So what we notice is when you take the derivative, this exponent comes in the front, and which means it multiplies, and you are going to have one less exponent. So the exponent has gone down from 3 to 2, and you have a multiplier. When you take the integration, the opposite happens. The exponent has actually gone up by 1, and you're dividing by that new exponent 3. So rather than multiplying here, you're dividing. So in general, if you were to take the derivative of x to the n plus 1, that's when you're going to have x to the nth power. And then you would be multiplying by by n plus 1. So if you were to start with, and since it's a constant, you can take inside the derivative, x to the n plus 1 over n plus 1 would give you x to the n. So now you can say that the integral of x to the n would be x to the n plus 1 divided by n plus 1. And be sure to add the constant of integration, because you're not going to get just one function but a family of functions. Now here is what I want to say is the power rule of integration. Whenever you integrate x to the n, you're going to get x to the n plus 1 over n plus 1 plus c. And notice that I actually left some gap, because whenever your formula says to divide, you just want to make sure that you're not dividing by 0. So this formula won't work if n plus 1 is 0. So provided that n is not equal to negative 1. That's what I wanted to write here. So when n is negative 1, what is integral of x to the negative 1? Well, in x to the negative 1 is simply 1 over x. Now, if you think about what function has this derivative, then you know that it's going to be natural log of x. But x could be negative as well, which means I'm going to take natural log of x plus c. So that's going to be the formula for integral of 1 over x. So this formula is good whenever n is not equal to negative 1. When n is equal to negative 1, you get that. And again, this formula applies for all real numbers n. It's not just a positive integer, but you can have negative integers, fractions, irrationals, anything except negative 1. You could even have 0 there.